Assalamu alaikum everyone. Myself Amna Noor and my registration number is 23TE29, and today I will be presenting my assignment on breadth first search and depth first search, which are two very important algorithms in artificial intelligence. In this video I will not only explain the concepts, but I will also walk you through different examples, and finally I will show you the implementation in Python along with the outputs. So basically, BFS and DFS are known as uniform search algorithms. What this means in that these algorithms do not have any prior knowledge about the goal. They simply explore the graph step by step in a systematic way. Now, why do we use them? We use these algorithms to find path between nodes, explore networks, solve problem where connections matter. For example, if you think about social media or even internet routing, these algorithms are working behind the scenes. So in simple word, they help us to understand how to move inside a network. Now let's understand this with a very simple tree example. We are starting from node A. First, let's talk about BFS. In BFS, the algorithm works level by level. So first it visits A, then it moves to B and C. After that, it goes to D, E, F and G. So the final order becomes A, B, C, D, E, F, G. Now DFS is different. DFS goes deep first, so starting from A, it goes to B, then D, then come back and visit E. After completing B side, it moves to C, then F, then G. So the order becomes A, B, D, E, C, F, G. So the main difference here is the approach. BFS level wise, DFS depth wise. Now let's move to graph traversal. Here the structure is not like a tree. Nodes are interconnected. We start again from node A. In BFS, first visit A, then its neighbor B and C. Then move to D and E. So the traversal becomes A, B, C, D, E. Now in DFS, start from A, go to B, then go deeper to D, then E, then backtrack and visit C. So you can clearly see that BFS spreads out first while DFS dives deep. Now let's move to a more practical interesting example, which is robot pathfinding. Here we have a grid where S represent the starting point, G represent the goal and X represent obstacles. So basically the robot has to move from S to G while avoiding obstacles. Now first let's understand how BFS works here. In BFS, the robot explores all possible positions step by step, level by level. It checks all nearby cells first before moving further. Because of this behavior, BFS always finds the shortest path. So this example, BFS will move outward from S, checking every possible direction and eventually reach G using the minimum number of steps. Now if we talk about DFS works differently. Instead of checking all direction, it follows one path completely until it either reaches the goal or gets stuck. So the robot might go in a long or even wrong direction first and only later backtrack. So in simple word, BFS is a safe and gives shortest path. DFS is faster sometimes but not always correct. Now let's see where these algorithms are actually used in real life. First, web crawling. Search engine uses BFS to explore web pages level by level so they do not miss important pages. Second, social networks. If you want to find the shortest connection between two pages, BFS is used. Now talking about DFS is a commonly used in maze solving. It goes deep into one path and if it fails, it backtracks and tries another. Also in file system, DFS is used to explore folders and subfolders deeply. So the choice of algorithms really depends on the problem. If shortest path is important, BFS. If deep exploration is needed, DFS. Now I will explain the implementation part of this assignment. First, let's talk about BFS function. In BFS, I used a queue data structure. The starting node is added first, then nodes are removed one by one from front. Their neighbors are added to the queue. This ensures that nodes are visited level by level. Now coming to DFS, DFS is implemented using recursion. This function visits a node, then it calls itself for its neighbor. This continues until all nodes are visited. Also in both algorithms, I use a visited set to make sure that nodes are not repeated. So overall BFS uses a queue while DFS uses a recursion on a stack. Now I will show you the code in Google Colab. Now I will run the code and show the output. I have created three different scenarios to make things more clear. First scenario is a social network. Here BFS explore connection level by level while DFS goes deeper into one connection before moving to other. Second scenario is a city map. In this case, BFS helps in finding shortest routes while DFS explores path in depth. Third scenario is a computer network. Again, BFS spreads across nodes step by step while DFS follows one branch deeply. So these outputs clearly demonstrate how both algorithms have. Now let's compare both algorithms. Both BFS and DFS have the same time complexity, which is shown there. But there are some key differences. BFS requires more memory, guarantee shortest path. DFS uses less memory, do not guarantee shortest path. So if we needed accuracy, BFS is better. If memory is limited, DFS can be useful. So to conclude, BFS works level by level and is best for shortest path problems. DFS works depth-wise and is useful when exploring deeply connected structures. Both algorithms are very useful in artificial intelligence and are widely used in real-world applications like navigation, networking, and search systems. Thank you.